name is Hyun Chul Shim. You can call me David. This is a name I used to go around when I was in the States. It's a great honor here to introduce my research. And so I've been working on various types of unmanned systems since 1991 when I started my unmanned aerial vehicle research in Seoul University. So that makes 1 year short of my 25th year anniversary next year. Starting a UAV, which is quite early. So I've been working on various types of unmanned systems, as you can find here. This is my work and hobby and my love. I like to work on real systems, and I like to build a control system, a theory on top of those things. So as you can see, I have many systems here. These unmanned systems, unmanned car, unmanned aerial vehicle. Some people ask me why I work on unmanned car, being an aerospace professor. Some people also ask me why I work on unmanned aerial vehicle, being a mechanical engineering graduate. But that's a kind of not very legit question. I think that's a more Korean type of question, because anyone interested in some kind of field, one can always venture out to do some multidisciplinary type of research. So my background is I'm a mechanical graduate mechanical major from my master's, PhD and everything. And also I started out in unmanned aerial vehicle, and also I have experience in the Hyundai Motor Company, so I know a car a little bit. And also my master's thesis was about the unmanned aerial vehicle, so I'm quite familiar with unmanned aerial vehicle so far. So I'm trying to merge those two things. So this is one nice little, marriage of those two technologies for flying and ground vehicle. But I'm just, that's one way. So my research is mostly based on some physical system and trying to automate it. As we try to automate it, those things don't work by themselves. So we have to come up with some kind of a system to automate it. And then that is what I call the component technology. So to automate it, we need a computer, algorithm, theory, and when I combine them together, I can make something very interesting, maybe even used for social purposes. So the whole conference is about the science and social impact. So this is one nice feature of that. This is a mining robot. This is used for a coal mine in Korea. I worked in a few years ago. And if you know Korean mining situation, we have to go down 400 meters down, and that's very hot, humid, a lot of dust. When you inhale it, some of those micro or nanoparticles stuck in your lung, and then that can cause cancer. So that's a very, very bad environment. So actually, I went down to the mine shaft twice, all the way down with my students, and tried to make the robot working. Fortunately or unfortunately, the project was canceled in third year because our company, the partner company, went bankrupt. In the same year, the reason I call it may be lucky for us, because the same year, the mine we're supposed to go into, Tebek mine, they had exploded accident. So if you were there, we might have suffered an accident, and I might not be able to see you here. That's kind of scary. So anyway, the technology is very amazing these days. It goes really fast, and sometimes I just amazed, and sometimes I feel myself short of breath just to keep track of all the fastly moving technology. So you might find it, you might have the same sentiment about the technology here. So recently, about 3 years ago, I opened up a center of field robotics, down there in the KI building, right next to the building. So in the third floor, we have a nice setup for those various type of robots, or a manned aerial vehicle, a manned ground vehicle, something like that. So if you have some time, just feel free to come into our center, and I'll be very happy to show you inside. So I was able to come up with some kind of vision-based landing system, indoor flight system. This is our centerpiece, our in-house flight control system with a full in-house code altogether. And recently, I'm working with some robot that automates the system, which I will show you later if I have some time. And also these things, when we combine those things, we can come up with a very interesting system that is customized for a certain application we are hoping to deliver. In this case, we Some of you probably have seen it, the strawberry delivery UAV, we did it last year, 2014. That was a quite interesting time because that was a time when North Korea allegedly sent us some very cheap some UAV for reconnaissance. So some of them were found crashed in a few places in Korea. So that quite caused frenzy in Korean society. So we have some kind of, which is quite good. We had the nomination for, we won, I think, the second prize of our National Instrument System Design Program car. This is our Prime Minister, previous Prime Minister, who was in KAIST, and I was demonstrating our indoor flight. He was very brave without knowing the danger. He was right here. He was flying right there. I was like, oh, look at you know, sometimes he was very brave. So we are working on various level technologies, platform technology, the aviation control, multi-agent-based information fusion, task assignment, path planning, with the collaboration of the 5 professors, including myself. Professor David Lee is a mechanical engineering professor, composite material STEL. He doesn't sound like a very robotic person, but he is actually doing the fuel cell. That kind of things are very useful for. But these days, the robot is great. Unmanned, for example, if you build Unmanned, all the exoskeleton suit, if you have it, that's great. But it will not fly today because there is no power source to power it. So he has a large reactor, right? The hypothetical reactor, and that probably deliver like a giga or tera zoo. So, but that power is needed, but we don't have it. So we need some kind of a power system. So he actually won a recent paper award for that, writing a paper about very lightweight, very compact fuel cell system. For example, I'll talk about later, but I'm not going to talk about here, but the drones, those drones, this thing only flies 10-20 minutes, only 11 kilometers range. So that can be doubled to tripled if we have a very nice fuel cell system. But fuel cell, of course, is expensive, and it has a lot of difficulty to use it for environmental factors, temperature, those things. And Professor Hyun Chul Shim is working on a multi-agent system. Professor Jin Lee, she's working on a GPS system. Professor Jinan Kim is a mechanical engineer. He's working on the unmanned surface vehicle, who won second prize of the Pan-Asia USB competition last year in Singapore. So probably, if you want to pardon the Korean letters, I have a few Korean letters to scale. I will pardon, ask for your understanding in advance. So this is very famous, a Korean fuel, and our Professor Ojin in our university, he won the world's, probably the single largest prize ever, right? $2 million. So that's a pretty big prize. And he won it. And the robots, manned robot systems are very popular these days. This is X-47B by Northrop Grumman. They built this UAV for full autonomous operation, from takeoff and landing, and even aerial refueling. So next time US may have some kind of conflict in wherever in the world, you might see this in action, not F-15 or F-22. Now, for your record, it's interesting, F-22 never been really actively involved in Korean warfare because that's just too expensive toy. And this is a Google car, they're really making this, trying so hard. Actually, I was in Mountain View last week. I saw one Google car going around. I was chasing around to see how it does. And I don't know if it's autonomous mode or whatever. There's a driver sitting in. Actually, I saw his hands going around like this, but maybe his car's driving by itself. Who knows? But well, they're testing it. They have 27 cars testing right now in Mountain View. So this is the Bebop drone, and I'm also a drone person. So this is a commercial version of the drone, costing about $1,000. So you can buy, fly these days. Although you have to be careful, some of you KAIST students, Daejeon is now declared no fly zone. So that severely cripples my research right now. So now I have to do an indoor flight. This is a curiosity rover. So latest recent advances in field robotics, UAV. This is probably the cutting edge. Audi and Google. Audi cars are amazing. They drove like 250 kilometers in Hockenheim Ring in Germany, that the racetrack. So 250 kilometers. Although there's no other cars, they experience a pre-programmed motion, but that we have to give some credit to it because it's so fast. If there's any kind of a sensor error, that propagates quite a lot because the cars move so fast that the 250 kilometers per hour. And now, right now, the Seaboard Patrol unmanned surface vehicle, unmanned underwater vehicle, and this is something you know, this is the Boston Dynamics spot. So, as tradition, people kick the robot, and now the animal activist says, don't harass robot dog. Okay, that's quite great. You know, now I was in the States, they were in the radio, they were talking about Cecil, the lion, full lion, who was decapitated, you know, or just trophy hunting. That was pretty bad. So, this kind of biomimetic robots are pretty, you know, very popular. The Hugo is also biomimetic because it mimics human body. Right? Also, this is a quite bad movie, Stealth. It's about the fully autonomous UAV, intelligent UAV, argues with the human. The colleague says something, he says, no, I don't want to do it, I want to do that. The kind of a fully intelligent UAV might come along in year 2014, 1545. This is an Audi car showed in the iRobot movie in Will Smith, right? That cars are awfully similar. They're actually they're really following the trend. And I don't know how many you saw this 10-year-old movie, but if you see the movie, there's the female detective saying, the Will Smith, who's also a detective, he's a doctor, saying that how dare you drive manually? how are you driving manually? You know, actually, driving is a quite difficult art. You know, you have to practice a few years, and you might even have a few accidents. I had actually 2 accidents myself, more than 20 years ago, as a learning curve, right? You know, some people may not be so lucky of walking out of the accident, right? So driving is difficult. Actually, I don't know how many of you actually have a driver license these days. Many of my students, class students, some of those don't even have the driver license. They think it's not really needed. There's the transportation. Korea has a very nice public transportation, so they don't really have it. Maybe later, maybe we have this, and then maybe they will have a different level of licensing. You might, so for example, right now, I think it's still there or not, but when I was taking my exam, you can get a license only for automatic transmission. You don't have a license, you can't drive manual transmission. It's very hard to find manual transmission car in Korea. There's still a lot of manual car in Europe, and in Korea it's very hard to see. And maybe later on, you may have a license to operate unmanned car, autonomous car, not drive autonomous car. You may have a special license for driving a car, like some people might have a license to fly an airplane, right? Maybe that kind of a year may come along. The computers are getting really fast, really advanced. So that's just happening. This one's also the cargo ship. You know, these ships takes a very, very long time, and then you need to have a crew to maintain. That was the old days. Now you may have an autonomous ship. So once the ship gets out of the port, the I don't know what's the name, the tugboat person goes along and press the button for auto cruise and get out. The ship seals itself and travel a few thousand kilometers just by itself, free from piracy. Right? Pirates get so long and they see no entrance, no crew to threaten, right? And they just get off and, oh, let's go other ship. So that may happen. Actually, the Lloyd in the UK, they are looking into this possibility. So actually, I don't know, this is about science and technology, society and technology. So this is a big problem. Actually, I was in TV 2 weeks ago, KBS and Unmanned, right, the Insight. And actually, I was showing up as a bad guy, getting rid of the jobs. So I'm building autonomous cars. So autonomous cars is a big problem because physically, there will be no drivers. Autonomous airplanes is a different story. Unmanned airplanes always need an operator. So one airplane is also still commanded by operators. So unmanned airplane doesn't really get rid of the pilot itself, but unmanned car really doesn't need the driver. So they say statistically in Korea, 3% of the population is actually working on the transportation, including bus driving, taxi driving, maybe ship, maybe airplane, but probably ship and airplane is not that much of the people, right? Number-wise. So probably a lot of the 3%, the majority of the 3% will be working on the ground transportation. So many of them may lose jobs, right? So that's actually a problem. So, but if you also look at it, maybe it's a little bit early to say about it, but 100 years ago, when they have the carriage and horses, they would have people feeding horses, watering the horses, and tour guides driving the carriage outside of the cabin, right? Now we don't really feel sorry about those people because of the cars came along, right? Maybe that kind of thing happens. That kind of a turmoil, little conflict always happens when there is a shift or transition of technology happens. So we need to be very careful. We need to provide some way to make a nice, smooth transition. But honestly, I'm a little bit pessimist myself. The humans always tend to choose hard landing instead of the soft landing when transition happens, like many World War, testify. Okay, so these robots, it's kind of a robot. We are kind of still stuck with the 4-leg robot. No, there's 3-leg robots, 5-leg robots, 2 legs with many arms. Our imagination is a little. We can come up with a very weird kind of robot. Actually, the competition, before Hugo came along, when Hugo won this final competition, but there was a pre-competition. The Shaft in Japan won the testing, the preliminary the competition, and they had a very weird-looking robot, mostly looking like a human, but they were arms attached here, not here, because of lower CG makes the robot more stable for walking. Okay, so what is an autonomous car? Autonomous car is a car with sensors and computing units and actuators. Many of these days, many of these actuators are already built in. But these cars will understand the surrounding environment and make the judgment to how to safely go to the destination while obeying the various implicit and explicit law of the traffic. This is very interesting. You might ask me, hey, Professor, you are aero guy. Why did you start unmanned car? Actually, I wanted to work on the rover, planetary rover. I thought aerospace professor working on unmanned car will be very nicely, ready to build a rover. But they didn't give a project actually. And while I'm working on this, unmanned car became so big. I started in 2009, and now everybody talk about unmanned car. Even today, I'm looking at down the Korean portal. They say the Tesla is just about to launch their new software. So if you got up, you find your Tesla software is updated like your iPhone does, then it's capable of unmanned driving. That's pretty cool, right? So the Tesla is these days led by Elon Musk. He's just amazing. So it has various sensors for its motion. That's pretty easy. GPS, I knew that gives you pretty good information. That is pretty standard navigation suite for aviation. But cars is not. The cars, when you drive, do you try to recognize your absolute position? Hey, I'm driving 36 degrees, or 45, minutes and what seconds. You don't really care for that. You are worrying about how much of a deviation you are having along the lane, right? It's relative driving, relative positioning is important. So you need a camera. You need the camera to detect the lanes. You need a laser scanner to detect the people. If you want to use laser scanner, but these days the laser scanner, they're trying to use more of the camera as the computing gets better and better. And you need what? You need the actuators to turn the steering wheel. You need the brake pedal actuation. You need the gas pedal actuation, or you might need just a computer communication. The thing is that these days, when you press the pedal, in old days, when you just 10 years or 5 years, when you press the pedal, there is a cable, opens the valve, throttle valve, and it allows the air to go in, and then it will have it go into the cylinder. But now when you press the pedal, this is no different from your gaming console. Just pressing just the switch. It's a potentiometer. So a computer reads it. Oh, driver wants to accelerate, but that is a computer's decision to let the car accelerate or not. Why they do that? They are doing this because of the pollution regulation. So they are when the driver abuses the pedal, making a lot of CO2 and NOx, that's not acceptable. So the computer makes a decision not to generate too much of this polluting, the gas. And so you can actually tap into the canvas, or you can hardwire the potentiometer, but these are automotive makers are not fools. They know they are really worrying about people hacking into the system in various levels, hardware level, software level, electrical level. So they usually give it to you the warning. So the check engine scientists comes up. So brake pedal can be also automated using electrical cylinders, or the shift lever can be shifted. But later on, these days, if you drive one of those nice hybrid cars or even electric cars, everything is already computer ready. So if you know how to tap into that, that's actually my problem. I have a BMW i3 for my testing car, and this car, it has everything ready for automation, but I just don't have the way to talk to the computer, because BMW are smart to block people like me from hacking the system. I might just RC the car, right? and put it on YouTube and all that stuff, right? So they have a few very severe level of block. So if we have some inside knowledge of if I have some help from BMW, it will make my life much easier, but that's not going to happen, right? So this is the early cars. This is interesting. This is German system. It looks like a pretty modern RC tank. This has the explosive. It has wired communication. So they RC. I have an RC controller. They're like that, and then they'll drive this under the tank, and boom, get the Russian tank just blown to pieces. And Russian guys came up with the opposite idea. They have a dog, starved dog, with explosive attached. And then when they train this dog, by training, they put a German tank with a lot of meat to eat on the tank, and these dogs develops the idea that, okay, the tank provides the meat. So when these dogs approaches it, hit the button, and so which will be more effective? Which was more effective, this or that?
No.
This one is more effective than this one because the wire was short.
Control is difficult.
But this is pretty well made. I saw some TV documentary. It was pretty well made. This is like I like Pebble, very nice engine-based RC tank. But this was much better. The reason why, at the time, 1940 something, we didn't have a computer. NEM was not even built at the time. The computing was pathetic, right? And this is interesting. This is the pigeon, and this is Skinner. You know the Skinner, the animals, the behavior psychologist. He used this pigeon to train to peck on the right military ship. So when you peck on that direction, then the missile steers to that direction to have the image showing up in the center. When the pigeon peck on the center of the project the screen, the missile goes straight and hit the target. So this is animal brain powered, automation, because we didn't know, we didn't have the computer. Now we have a computer, right? Now we have a computer. This is a Luna code. Who is a United States Luna car was the first, or this Luna code by Russian, space agency was first to roam over the lunar surface, which is first. This was first. They lost the space race, lunar race, to send the humans, to spoil the competition, to win in any way. They sent this very early version of a rover, but they didn't have the computer. And to the moon, it only takes a fraction of seconds to travel for the light, right? So they sent, I told you, 1 second, right? So 1 second to travel, 1 to come back. So they use the remote control with a 2 seconds of delay. So they had to predict it, right? But so they were pretty successful driving it, but eventually they crashed, right? Into the roll down into crater, they lost it. But now this rover drives in the Mars surface, and sometimes it takes 20 minutes, sometimes it takes longer when Mars is the other side of the sun, right? So it takes very long time, so they need autonomy. So this was my favorite show back in 1980. So some of the old timers back there recognize that, right? It's David Hasselhoff. He was driving this Knight Rider that was really impacting my life, right? That makes me. At the time, there was another show called Aerospace. That also affected me. So that exactly pictures shaped me to work on unmanned helicopter and unmanned cars. So be careful what you're watching when you're younger. So it was a very interesting day, and then now we almost have everything. This was a really dream at the time. He called the car using his wristwatch. I have the Apple Watch. Hey, come to you, right? Siri answers to me. And this car drives by itself with some kind of sensor, and this smart mouse computer answers back to you, which is a Siri, right? Which is great. I just bought the Amazon Echo. I can turn on and off the lamps around my home. So my son says, oh, we are living in 22nd century, right? 22nd century. Right? This is also the early days, the Carnegie Mellon's unmanned car, lab. They did a lot of work. Actually, the unmanned car research these days was shaped by the people from these research. Sebastian Trun, Brad Whitaker, those people are overseeing new people. So it is not really surprising. And there was one interesting project by California UC people. This is a PATH project back in 1990s. The cars driving very closely by themselves, autonomously along the highway. The idea behind this is that, okay, if you have more cars in the given length, you will be increasing the throughput of the highway, so you can actually get more cars passing. The idea was great. They did the experiment. That was a time just before the computer vision. So how did they drive it? They dug a little hole and insert a magnet. So there's a sensor for magnet, and the car seeks the magnet. It tries to center the car with respect to the magnet. Okay. So it's like you're driving like this. Do you drive like this? You drive like this with a preview, right? So this car jitters along a little bit. So the computer has to be really fast to react on it, right? So at the end of the project, one of my colleagues, Yana, right? Her name, she worked on a very primitive version of computer vision to follow the lane. So she's, I think, a mother of all the lane following control. So she did a very nice work, and the car drives much faster, but the project was ended. Right? He's a Professor Min-Hong Han in Korea. He was at Korea University, the professor. Now he retired. But he was very brave to drive this car still. Sometimes, I don't know, he's still doing it today, but he's driving this Mati small car unmanned in highway and forward. So if you go to internet and screen people, Cheongan-ka, type it, then you might find his website. His work still working. But still, it's undeniable that it's a DARPA Grand Challenge who put the autonomous driving as we know now. Stanley won a poetic justice. He's a poetic justice on these two strong competitors from the Carnegie Mellon. So they won it, and then there was another team. This is the idea of this behind the motivation was to try to come up with a military car that drives around between the cities, between Baghdad and some other Fallujah, right? There's a city like that. The motivation was, I was told from my professor, my advisor, Shankar Sastry, UC Berkeley, he says that the military servicemen or women, they are of course the top reason for casualty is during the firefighting, right, war fighting, and second largest reason is when they are moving along the cities, because the driver because of all the fatigue, he get tired, he roll off the road and get a crash. Or there is an IED, improvised explosive device, installed along the road, and boom, and people die. So why bother driving? Let the car drive itself. So DARPA is always an amazing agency. They are looking into the trend, and they set the goal, and they put out a challenge, and they encourage the researchers in the United States and around the world sometimes to participate in this direction. So that the most recent one was DARPA Robotics Challenge that ended about 2 months ago, and this was the year 2005. And at the time, people believed that the car would not be able to drive by itself without the help of the external devices like magnets. But now the computer or computer vision, at the time they used the laser very dominantly. But later on, they did the DARPA the Urban Challenge. They used computer a lot. This is a Stanley on display of the Smithsonian Museum. That's pretty honor, right? The Smithsonian Museum, they have Wright brothers, the Apollo rockets, and now they put on display. Pretty nice. And this is a pretty long distance. You know, this is 240 kilometers to drive by itself. It's quite amazing, right? If I have my car, hit the button, it will go to Seoul by itself, driving. I have a car, honestly, sadly, I have to admit that my car is not ready to take on such a mission. Of course, but if the road is clear, it might be, but still it's very difficult. And later on, the Urban Challenge came along, and then CMU, they vindicated, and then still Stanford won second prize, and then a lot of this technology went to Google, as you know. And then, this is quite interesting. This is the very famous Dennis Hong, Korean-American professor, who actually competed also in the Robotics Challenge. And he won third prize, and the MIT, there is a first entrance, but they won fourth place, but they did have pretty good stuff. So in the world, sorry about the Korean, but there's an entire world now going after unmanned car technology, right? There's even newcomers. So the CMU, they did a pretty nice job, but they are not as active as the Stanley. But recently they had a pretty big loss of research people because the company for the new way of a taxi service, what is the company's name? Uber. Uber took a lot of people, paying almost double or even more money to the research members, and now they all exited, they left CMU Research Center for Uber Research Center. So now the CMU is complaining, hey, don't go. But more money right now. And the Nissan is also working on unmanned cars. Audi is working on unmanned cars. Hyundai Motors is Korean company. They're also doing it. And this is interesting. I think this is now implemented. Some low-speed unmanned driving capabilities now implemented, now available to purchase in Audi A4. So you might consider buying one. So Google. I saw Google cars. So I don't know how many of you Google cars on the street. So I'll show it to you. I took the picture. Korean called Jik. So I was chasing around. Hey, I was chasing around. So the biggest, actually I have a longer version. But I took with my Google Glass. I don't have it here. Sorry about that. I don't know what the color, sorry about that. So I have another version. So this is a Lexus RX 3 whatever based car, and you see a lot of the sensors going on there. They operate actually 27 of the same identical cars and building a lot of mileage for that. It's just amazing. So this car was also provided by Lexus, I was told, and then first they didn't have the steering wheel, but later on, the people criticized that's too dangerous, so later they put the steering wheel back. So they say Google believes that the autonomous car has to be built from scratch, not partially automating, this and that and that. That's their belief. There's a Christopher Omsen, right? He's believing that that is the way they have to do. So they're building the car that way. So I saw the latest Google car, not the one on the picture. They have a newer version of sensors. So they are probably making the car a little bit better. So the other way is the Mercedes-Benz. Actually, Google started early. They are saying that they are building the car, but they didn't care. Okay, you're Google. You're doing a lot of crazy stuff, right? Google does the car, some undisclosed things like the Project X, right? They're doing a lot of things, but it was actually the Mercedes-Benz quickly put the unmanned car technology in the center stage. So Dr. Dieter Zetsche, right? I learned German in my high school days. Probably that's the way the right way. And he announced that the Mercedes Daimler-Benz will commercialize autonomous car by 2020. Suddenly he announced it. After that, everybody was just like, ooh, this is going to happen. And even Hyundai was asked, hey, are you going to do it? Yeah, we were working on it. So they are doing a different path. They are trying to make the car more like a existing car. You can really say this unmanned car, right? Now, Google car, this is unmanned, that is modified, but this doesn't look like one, right? But they have all the sensors hidden inside of everything. And he's obviously drive autonomously, but this looks like the unmanned car, right? But it's interesting that Mercedes-Benz always say, hey, we don't really care about Google things. But it is actually, they're showing that they are really are conscious of what Google's doing. Because this design, it looks awfully similar, if you ask me, with this. Well, I'm not saying they are copied or whatever, but they are building the car totally out of a different shape. They used to build like this, but nowadays the car is looking like this. If you go to the YouTube, search for F105, just amazing. The people are facing each other. They are saying that they are restoring old-fashioned driving the carriage. If you watch the old movie like Amadeus or something, there are people sitting facing each other. Right? That's the old way. So they're trying to bring it back. So this is just amazing that they are building a car with much cheaper sensors, the camera-based sensors. Camera is amazing. We drive with our eyes, right? We don't use ultrasounds like the bats do, or right? The EMP. Right? We use our eyes for mass emission. So the camera base, that's what they're doing, and the computer vision gets better and better and better. And I was in the talk last week, just a few days ago, by Cisco. They're saying, in a few years, we might have a computer system capable of teraflops. Now we have a computer with gigaflops. So that if you have more computing, it will be possible. So Audi, amazing car. Audi I downplayed, but Audi is a really great car technology for non-kilometers driving. And BMW is not doing much, to my understanding. UK is doing something, Japan is working on something. Japan is trying to come up with a highway-capable autonomous car by year 2018, when the Tokyo Olympic is, I think, right? And then smart mobility, close, the community for self-sustained energy. And if you compare two, Google's focusing on the autonomous driving from scratch. Car makers trying to augment existing car. That's where the philosophical differences mainly lying on. And also the intelligent obstacle detection. And they all work, and they're more sensor-based. ADAS score. They're very optimistic. They are careful, and the autonomous system will be held and responsible. And drivers will be held and responsible for safety. So in Korea, I competed for Hyundai Challenge, what I call. And we had the 3 events so far. They may not have year 2016, depending on how they do it with their business, I think. And then we did a lot of interesting events. And I did it very hard. I tried so hard. And then when heaven don't help you, that's pretty difficult. When I was driving, it rained. So if you go to YouTube, if you find one, let me know. Autonomous driving in rainy conditions. That's really difficult. The Google, I lived personally in San Francisco for 12 years. San Francisco is an amazing place. It is a lab condition. No rain, always sunny, dry, lowly populated area than here, right? And the people relatively are much better obey the law, not here, right? So, traffic. So they are doing great. Here, crazy, very difficult. Rain, snow, all the things. So this year, 2010, we competed and we did something nice. We crashed in here, very bad. This still is my trauma, mentally. Okay, and then that was our first car. And I was working here like this. I was actually writing the code, and in this place there's a exhaust gas pipe, and it goes in my nose, and then I had a terrible headache. I think I lost 5 points in my IQ. Probably my brain cells killed a little bit. So I felt sorry for my students. So I bought a next car, but this is the first generation car. This is second generation car, the competition, so they made a very nice video for that. Oh, yeah. He's from Unmanned University, that's my student. He's crying, virtually overwhelmed. So, that's not our car. That's our team. That's our team. So we did pretty well. In second day, we messed up the first day. So that is our problem. So we did a lot of the theoretical stuff, which I'm not going to go into detail. And some stuff about the optical avoidance and the crossway detection, lights, and everything. We are always bad at pedestrian detection. Just passed. We're supposed to stop there. And going like that, passing the car, like that, like that. That was 2012. We did pretty well. 2014, so now we are converting the car to Veloster, which is pretty second fastest car Hyundai has to offer. The fastest car is the Genesis Coupe. So we bought the now BMW i3 partly for my students because they are suffering from brain damage from the exhaust gas. This one, even driving, exhaust gas goes recirculate. That's pretty awake technology. Even driving, exhaust gas goes back into the cabin. I don't know how they do that. So that's very bad. So this one is very nice, no exhaust gas. So I have this car for my driving experience these days, but we have this car, so we modify the computer there. Crashed. I don't know what's this time. Sorry about that. Sorry about the technology issues here. Anyway, I was almost finishing my talk. I'd like just to show the video of 2014. I have some more stuff to discuss, but I pretty give you a good overview of technology here. So why don't I first try to get some question while I'm trying to recover my computer. Any question here to make our time more useful? Any question here? Okay, go ahead, please.
Thank you for the presentation. My name is Hyun Kim from ICISTS, and I heard that
the agent, whatever, to drive the car. Now that paradigm, that central belief is about to break, because human is not the only one can drive it. And you may even ask if human is the best driver ever. So far, we are the best driver, right? Your cat can't drive, right? Your computer can't drive. But right now, computer gets much faster, and these sensors are detecting 80 meters around 10 times of a second. You can rotate your head 10 times, right? And you can detect the centimeter accuracy without ceasing. Of course, they can break down. But, just amazing. This radar constantly monitors in front of you, even you are texting. Human drivers are not the safe drivers. So we have 5,000 people killed everywhere in Korea. In the United States, more than 10,000 people. In global, 100,000 people are killed every year. That is single most, I think, the casualty ever. That's a huge number. And if we can reduce the number by half, reduce the number by 1/10 by machine driving, constantly monitoring without any tire situation, then we may have give it a shot, right? And human is great in many things, but human is not great when it demands constant attention. We get easily tired, bored, fatigued, right? And truck drivers, they drink, energy drinks, right, to get themselves awake. That's all the problem. So we don't know how far we'll go with the technology down the road, but there's a great potential, and we may even rethink later on. For example, I have a car with adaptive cruise with emergency brake system. So this radar has a Doppler radar, so it detects the car closing in. So it hits the brake before you know. So for human drivers to know the relative distance, especially the closing rate, you have to constantly monitor the size of the car. If the car gets larger, you're getting closer. If the car gets smaller, you are. When you say larger and smaller, there is relative sense. So you need to constantly compare in your brain. That means you need to keep your eye on the road. That's why people say you need to keep your eye on the road to compare how far the car is closing into you. But this device just measuring Doppler shift. It knows it's closing or not. That's amazing, right? And so these technologies actually in the United States, if your car is equipped with an AEB system, they lower your insurance rate. So they already know this helps. So down the road, this will be interesting. And down the road, more sensor capability with the greater computing power, it may be even possible. That may be a little optimistic, but the car may be even better than human driver. So later on, you might say, 100 years old, and 30 years later, your granddaughter says, "Hey, I heard you used to drive. How did you do that?" So that's actually the Google I say. So while I'm trying to keep the people out of the driving seat, sometimes you feel the pleasure. But how often do you really feel the pleasure of driving? How often are you, right? In Korea, especially. Usually you feel the pressure, not the pleasure. So you have a lot of things to think about, social impact and everything. The technology is really getting there. I'm quite optimistic. Maybe 100% autonomous driving is hard to come by, but maybe 90% will be greatly helping you. Some people say it's different things, but I'm a little bit optimistic. Okay.
Hi, my name is Chris Lee, and I'm a sophomore here at KAIST. And I just, you said it's really hard to make an automated drive a car in rain and other, bad weather situation. And there really isn't set any regulations or laws about self-driving cars either. So, what do you think in how many years, there will actually be automated cars in the road with, complete regulations and, doesn't matter what the weather is?
The fully unmanned car, 100% unmanned, so actually the car is really empty. The kind of cars, I think, it will take at least 10 years, I believe. But Mercedes says 2020 somehow, so I don't know. I don't really share that. Maybe they have a really great stuff there, which I don't have. But as you can see here, the sensors suffer a lot. A lot of these sensors are designed and tested on sunny California, right? So they have a lot of trouble. We had a lot of trouble. We were sent to start in rainy conditions. I naively put these 2 videos on our YouTube account in our lab, and I triply covered our 2 videos. Some guy in Korea somehow put and showed usually other research agency would hide. So I didn't really, I thought, well, that's not to hide, right? We just share. I think this video is the single most viewed in our channel, our lab channel. They look at a lot, hundreds, thousands of hits already. And they are seeing it, and they try to see a lot of things. You can see here when the car is facing the sun. That's really, even in Korea, we have a very bad weather pollution. So when the sun goes down, it shines red, a bright red disc. But if you go to the United States, that's the most difficult time to drive because sun's sitting right there. Your eyes are suffering like these problems. You have bright background. You don't even see what it means, what it says, right? You can see it in the sun is back there. So that kind of problem. Actually, that's what Tesla says. Tesla says they are really about to announce their autonomous driving software. They are having great difficulty to detect faint white line on the concrete road in about sunset time. It's what you're saying. But the software gets better, computer gets better. If you look at the CCD these days, your camera, your iPhone, when the sun is setting, you're turning it on, this screen shines better, shines clearer than your actually eyes see. That means it gets better than your eyes. That recently the advances has been made. So I think sensors will get better with multiple sensors. So for example, the radar. I don't have a radar here. Radar is very hard to use. Hard to acquire in the universities. But if you have a radar, you have a lot of great capabilities, like who's using it. So I think it's possible. Here we are supposed to study one of those people, but if you look at the camera, all looking like this, all fogged up, right? So very hard to see. So we are not perfect by far. So if you are anybody interested in this technology, I'd like you to have in my lab. Challenge. I have openings, I have fundings, I have 3 cars to play with. So one of the cars has pollution issues, gas issues. So if you want to challenge yourself, this would be amazing technology. So I'm recruiting here.